All the trigonometry you've learned so far is based on a right angle triangle. So like SOHCAHTOA works for right angle triangle. Now what if the triangle is not right angle? We've seen the technique before. Maybe you can draw a perpendicular line like we did in the quiz and try to work out the height, then work out the other side. But this is not convenient. We need to be able to come up with a formula. And before we come up with the formula is to do an investigation. There's a triangle in front of you with all the sides measured, all the angles measured. Let's see if there's any connection between the side and the angle. So what we do is, let's write down the angle and the side. First, let's complete the table. So angle A is 56 degrees. Angle B is 37 degrees. Angle C is 87 degrees. And the side length for A is 18 millimeters. Just write 18. And then B is... A is this length, the side opposite to angle A. So it's not 18. Oops, sorry about that. A is the side opposite to the angle A, so it will be 25. B will be the side opposite to angle B, which is 18. And C will be the side opposite to angle C, which is 30. Okay, so when you look at the numbers, there doesn't seem to be any connection between the angles and the side, other than the bigger the angle, the bigger the side length, isn't it? But there's still no, we need to see if there's any connection. So what we do is, let's experimentally find the value of A over sine A on your calculator. So on your calculator, do A, which is 25, over sine 56, close bracket. Give you 30.15, or just 30.1, 30.2. All right, just write 30.2. Correct to two decimal place, one decimal place. Let's try another one. Do 18 over sine of 37. Close bracket equal 29.9. Okay, and then we'll do the last one. 30 over sine 87. Close bracket. 30 point, or just 30. Okay, so what's the conclusion we could make? Now, of course, there will be some error on your measurement. It's not exactly 25, 30, 18. So, but roughly speaking, we can see that the three ratio are roughly equal. They're roughly equal to each other. And due to this result, we can conclude, or at least we can believe this formula works. That the ratio of the side length over to the sine of the opposite angle is the same for all three sides. And that gives us a formula to calculate the missing side using this formula. This formula is called the sine rule. Okay, the sine rule. Okay, let's use this formula to calculate x on this diagram. Okay, we can calculate x now. So what you do is, using this formula, we start with x. X is opposite to this angle, so you do x over sine 57. And you pick another side, which is 8, opposite to sine of 62. Then we can solve for x. Now we have an equation. You don't need all three. You just need two. One missing side, one side that's given. Let's find out what x is. Multiply both sides by sine 57. That get cancelled. And we end up getting x equal to 8 sine 57 over sine 62. Okay. Let's use your calculator. So using your calculator, you will get 8 sine 57 divided by sine 62 equal. You will get 7.560 7.560 7.6. Okay, 7.6 in 1 decimal place. Okay, no unit. Okay, good, pretty easy. This is called the sine rule, which is this formula here. Now you need to memorize it for the test. During the test, we will not give you this formula, but it's not hard to remember. All you have to do is do the sine length, opposite, divide by sine of the angle, another sine length, divide by sine of the other angle opposite to that side. All right, we've got another formula. What if you want to find the missing angle? Well, you just flip it. Right, you put the sine A on the top over A, sine B over B over B. It's the same formula. We'll put the sine A on the top because we're finding the angle. So to find the angle, we'll do the same thing. You use this formula. So we've got theta here, which I forgot to label. Okay, but anyway, so you go sine theta opposite to 8. So write sine theta over 8 equal, because it's sine theta on top, you have to start with the angle, sine 52 over 12. There's your equation. And now it's just a matter of solving this equation for theta. So what do you do to solve the equation? Multiply both sides by 8 to clear the denominator. And you end up getting sine theta equal. Now you can just work out on a calculator. Let's do that. Do sine 52, make sure you close your bracket, times by 8 divided by 12. 0.525. Now remember, that's not your angle. To get the angle, you have to do shift sine, inverse sine. So you have to do inverse sine on this. So you go shift sine, answer, correct to 1 decimal place will be 31.7 degrees. Of course, you know how to do it in minutes, so you want to be in minutes. 31 degrees, 41 minutes. Okay, so by pressing this button. Okay, good. Try the next one. So it's very convenient formula. This is called the sine rule. Let's continue. Try the next one. Have a try. Find theta. So start with the angle sine theta over something, 6 equal to sine 40 over 4, and solve for theta. Okay, very convenient. Just take a couple of steps. Okay, all right, let's do that. Okay, good. Let's do sine theta over 6 equal to sine 40 over 4. Multiply both sides by 6. That cancels the denominator. Work this out on a calculator. So you go sine 40, close bracket, times by 6, divide by 4. Equal to 0.964 something. Dot, dot, dot. Remember, when you find angle, you must do shift sign of your answer. Press equal. 74.6. 74.6 degrees. Theta. That is. Oh, there's a problem. Does that actually match the diagram? Does the angle match the diagram? What? Yeah, but it's actually obtuse, isn't it? This is not obtuse. So what happens is, when it is an obtuse angle, you have to do something special. You have to subtract from 180. Now remember, from the previous exercise, remember sine is positive in the first quadrant when it's acute, or in the second quadrant. So actually going back to the last lesson, if you still remember, for the same ratio, when sine theta is half, it can be 30 degree acute or obtuse. In this case, we want the obtuse angle. To get the obtuse angle, we must do 180 minus. So what you need to do, the workout that is required, yeah, so you have to go like this. So you just have to write theta equal, let's rub this off, theta equals to 180 subtract sine inverse of this number. So using your calculator, you do 180 minus the answer you just got, 105 degrees, 105.4 degrees. Okay, so that's what you do when it is obtuse angle. Remember to do this step. So that's a special thing you have to remember. Otherwise, you just do it normally. Any question? That one's not to scale. But this one, deliberately, that's acute. Okay, that's not to scale. But the question will specify, they will say theta is obtuse. But definitely it's still acute. This is still acute, right? Does it look acute? I think it's acute. I have to think. Will it work? I don't know. Okay, anyway, let's skip that. Okay, good. Let's move on. We need to do another page because we need to do more work. We missed a few lessons already, so we need to go through this. Okay, cosine rule. So there's two rules you have to learn. Oh, sorry. Okay, we'll keep it obtuse. Obtuse. Okay, all right. So what we have, actually, that's a good point. Let's go back to here. Now, if it's a, let me think. Okay, now, if it's obtuse, let's say it's obtuse. Say you were right. You do 180 minus 31.7 degrees. You get 148. Right, this angle is 148. But what if you add the 52? You get 200. So it can't be obtuse, if you know what I mean. So you can tell by adding the 52 degree to the obtuse angle. If it's more than 180, that can't be obtuse. So it's a good question. Okay, good. Move on. All right, there's two rules you have to learn. There's the sine rule. There's also the cosine rule. We'll go through the cosine rule. Okay, go to next page, which is a little bit more complicated. So let's look at it very carefully. Okay, now if you look at it, it's actually not that hard. What formula does that remind you of? Pythagoras, yeah. So if you just take this bit, this is exactly Pythagoras, isn't it? So when it is not a right angle triangle, we have the extra minus AB cos C. Now, in fact, it does become Pythagoras when this is 90 degrees, isn't it? Now, when this is 90, what does cos 90 become? We just learned that a couple of days ago. 1. No, not 1. Now, if you draw the unit circle, 1, this is 0, 1. What's cos? 0. And what happens if this is 0? It disappears. You get Pythagoras, isn't it? Does that make sense? If you put 90 there, you get 0. Cos 90 is 0. So you can think of Pythagoras as a special case of the cosine rule. So the cosine rule generalizes the formula to any triangle. Doesn't matter it's right angle or not right angle. Okay? So let me write a statement so that you can write something down. So when it's 90 degrees, the formula becomes c squared equal to a squared plus b squared minus 2ab cos 90. But cos 90 is 0. If you still not sure what that is, just press the button on your calculator. You will get 0. Okay? So since it's 0, that will make the whole thing 0. So therefore, the formula will just become the Pythagoras 0, as expected. Okay? So when it is not 90 degrees, use the cosine rule. So let's use the cosine rule to work things out. Okay, let's have a look. So we've got this example. We're going to work out the B, right? You can think of B as like a hypotenuse, except it's not a hypotenuse. It's a hypotenuse if this is 90 degrees, but if it's not 90, we'll use the cosine rule. Okay, so let's go through this. So let's do b. So the formula is this: c squared. So this is b squared. So start with b squared equal 12 squared plus a squared. That's your a and b. It doesn't matter which one. B squared equal to 12 squared plus b squared, a squared. But because there's a 75 degrees, you subtract by 2 times 12 times 8 cos 75. So it's pretty easy. Yeah. Let's try again. So 12 squared plus a squared minus double the product of these two, cos of 75. And then you just have to work out. Let me write a bit smaller so that it fits on the page. I'm going to rub off again. Write a bit smaller so I have enough space. So you write b squared equal to 12 squared plus a squared minus 2 times 12 times 8 cos 75. All right, let's use your calculator. 12 squared plus a squared minus 2 times 12 times 8 cos 75. You get this. 158.3. Dot, dot, dot. And like Pythagoras theorem, you have to square root your answer to get 12.58. 12.58 to 2 decimal places. Any question? Yep. Yeah, but you don't have to. What you do is, for this formula to work, whenever you have these two sides given, so let me use a highlighter, you have this and an angle. So it's like SAS. The angle, the side you're finding is the side opposite to the given angle. And this side will be called C. I know we'll label that C there, but the formula will become complicated if you use that as a B. Because if you write it that way, so say you wrote, that's your C, you wrote 12 square equal to A square plus B square minus 2 times B times 8 cos, and you don't have this angle. Does that make sense? Yeah, so it's hard to use it. So you don't have to use exactly the same letter, you just have to have the right angle and the side length. Yeah. Now the next question, why can't I use the sine rule for this question? If I were to use the sine rule, it doesn't work because B over sine 75, I need at least another angle, isn't it? To work out the missing side. So I don't have the angle here to work out to match with the 8, so I can't use the sine rule. Therefore, I have to use the cosine rule. Yeah. Okay, good. Let's continue. Let's do more. Yeah, we'll this is the last page, and then you'll start the exercise. We'll do the area tomorrow. I was planning to do all 3 pages, but maybe we'll just leave to 2 pages. I don't know. Okay, let's continue. Finding the angle. You can also find angle using this formula. Now, because cosine rule is a little bit complicated, unlike the sine rule, I could just flip the formula, isn't it? I can't flip the formula there to find cos C. I have to do some algebra to do cos C. So if I rearrange the formula, I should get this, right? Now the question is, how do I do that? Well, the question, it's actually quite easy. So let me show you how it's done. But you don't have to know that. You just have to memorize the formula. So let's write down the rule. C squared equal to A squared plus B squared minus 2AB cos C. And then what you do is, let's rearrange. Move this guy on the left. 2AB cos C equal A squared plus B squared. And then move the C squared to the right. So I swap them. So it's like I put the negative to the left and put the positive back to the right. I swap them. And then what you do is you just have to divide both sides by 2AB, divide by 2AB, cross, cross. That gives you cos C. Alright, so these are the formulas that you learned today, so let's highlight them. It's very important. Like that, formulas. I encourage you to do the same with the sine rule and the sine rule. So these are important formulas. Make sure you memorize them. Regardless whether you're doing advanced maths or general maths, these formulas will be used again in the year 11 and year 12. So this is important. So regardless what level of maths you're doing, you need to know sine rule, cosine rule, because they're useful. Okay? Because in general, most triangles are not right angle. There can be any angle. So these formulas will be handy. All right, let's use that formula to find out theta. Okay? Let's find theta. Now, how do we find theta? We're going to do the following. Okay, let's use the formula. So this is how it works. So we use the cosine rule when all three sides are given. SSS. No angles given. So you have to use the cosine rule. So what you do is we go cos theta equal. Now, how do I know which one's the A, which one's the B, which one's the C? The C is always opposite to theta. The C is always opposite to theta. So therefore, these guys are A and B. So you write A squared plus 10 squared minus the 5 squared. Yeah. So the C is the 5. Okay, opposite to the angle. And then you have to do that again over 2 times 8 and 10 again. Right? Okay, so let's work this out on your calculator. Let's see what you get. So we're going to do fraction 8 squared plus 10 squared minus 5 squared. Yep, yep, good. All right, continue. Okay, let's work this out on a calculator. So you go 2 times 8 times 10. Okay, this gives you 139 over 160. Now, like before, to find angle, you must do shift cos. So you go shift cos of the answer to give you the angle correct to the nearest minute. That thing, 29 degree 41 minute. Okay, so you go theta equal cos inverse of 139 over 160 equals to this angle, 29 degree 41, 29, 41. There's your answer. So today we did something amazing. We learned 2 formulas, sine rule and cosine rule in one lesson. And we worked out to, yeah, I know, we're going to do one more. Okay, now, what if you want to find out the greatest angle? Which angle will be the greatest? Yes, let's rub this off. The one angle that's the greatest angle must be opposite to the longest side. That's the longest angle. Opposite longest side. So if a question asks you to find the longest, the largest angle, you know where to find it. And of course, smallest angle will be the 29 degree opposite to theta. Okay, let's try to work out. So let's call this angle, I'll just call alpha. Okay, alpha. Let's do alpha. Yep, let's find alpha. Usually Greek letters are used to stand angles. So let's go cos alpha equal. Now this time 10 is the C, right? So you go 5 squared plus 8 squared minus the 10 squared. Right? The C is the 10. Over 2 times 5 times 8. Let's work this out on a calculator. So we go 5 squared, 5 squared plus 8 squared minus 10 squared over 2 times 5 times 8. You get negative. But we'll learn something. What happens if the cos ratio is negative? What does it tell you about the angle? It's obtuse. It must be obtuse. But cos is a little bit more advanced than sine. You don't have to do that 180 minus business. you can just go shift cos of the answer. So if I do shift cos of a negative angle, of a negative ratio, it gives you a obtuse angle straight away. I don't have to do 180 minus. So cos is a little bit better because we know cos of a negative ratio is an obtuse angle. So that gives you obtuse angle to the nearest minute will be 97 degree 54 minutes. Alright, so cos ratio is a bit better. Okay, any question? Now, is there a proof for the formula? In the next lesson, we'll go through the proof of the formula and also find another formula for sine. Okay? But now just have to learn these formulas. Okay, thank you. Alright. If you have a question, ask me. That's good.